up on day number 2 of the conference. I'm Maria Dykstra, and I'm with the Digital Marketing Strategy Company. And it's my honor to introduce Dr. Ying Li. Dr. Ying Li grew up in digital advertising. She started working in digital before we even knew what it was. So she started at the time when GIFs and JPEGs and being able to target male versus female was the sophistication and the art of digital and online advertising. She's also holder of over 70 patents that are responsible for the technology that we use today in digital marketing and advertising. And today she will be talking about the future of science and how the science will redefine the paradigm of advertising and marketing. Without further ado, Dr. Ying Li.
Good morning, everyone. Let's see. Okay. All right. I will go back a little bit further than what Maria introduced me. I was trained as a mathematician. Growing up, I studied math and undergraduate masters in math. And a colleague of mine used to comment, the stuff we were working on has the shortest distance from math to money. And this was referring to the behavior targeting days we were building behavior targeting engines. So today, I want to share with you our data scientist perspective in looking back what I have done and what my colleagues and different companies and the industry have done, and shedding some light on the upcoming new things that I see. In particularly, introduce the wisdom pyramid. How many of you know wisdom pyramid? A couple. And introduce the components of knowledge systems that we are building, hopefully to inspire some thoughts about what to anticipate. And so today, large companies, internet companies, Google, Bing, Facebook, you name it, as well as some ambitious small startups are also focusing some of the investment on knowledge systems. And these have implications to what you do, what we do here in advertising and marketing. And I want to share my perspectives with you. So I have been a data scientist for about 15 years. I introduced the data mining to Microsoft Online Service Division, built different web mining, usage tracking, behavior analysis, and these technologies that in those days include tracking the web usage, analyzing your click path, the funnel analysis, all of these things. That was about 15 years ago. And these things naturally have an application in the advertising space. So as we shifted into advertising space about 10 years ago, these algorithms naturally lend itself to different algorithmic engines. And I actually led the engineering team build the behavior targeting products, and as well as other targeting products for Microsoft. So this is a web page I credit to Microsoft as today, the behavior targeting product that's being sold still. And in doing this, and of course other companies provide behavior targeting solutions and products as well. So let me quote a couple. We can make online advertising even more relevant and useful by using additional information. And we can find precisely the consumers you're looking for, and you can focus your campaign. And so you can see the promise here is precision and relevance. So this is, and then how did we do this? And how well did we do it? Obviously, when you think about these claims, we do need large quantity of data behind to actually be able to do this, to make it precise, to make it relevant. So we actually work with hundreds of millions of users billions of impressions and terabytes of data each day. So this amount of data actually go through systems. And this is not just this big internet companies. This was so maybe 10 years ago, but it's not necessarily so today. And smaller startup, because of the computing power, because of availability of data, because of the more people are working in data science and availability of algorithmic engines, these are becoming affordable to actually build into products. So how did we achieve precision and relevance? So let me walk through a short snapshot. So this is a snapshot of a sequence of queries made to Bing. I actually made this. This was around the year end of 2010. You can do a quick scan. This is an unaltered query. I did not know I was doing this. And I was playing our system, and I actually, because I know my user ID, I can capture it in that system. I actually reached, after the fact, I captured it, so I kept it used as an example. So you can see, look at this. You can say, we can reasonably infer something, right? So you can see music is there, Pandora. You can see science. You can see some schools and crafts and some others. And then you can infer that possibly related to Chinese language, probably speak. And it's possible, maybe a little bit harder to infer that the school was actually meant for applying for schools. You see a couple schools because you have the hint of ISEE, the number 4 from the left, ISEE practice test. So you take those tests to enter those schools, to apply to schools. Crafts supply for origami. You see there's origami, there's crafts. So if you are willing to cross-reference the different queries, combine the queries together, then you can infer a bit more stuff. And you can even infer possibly, I'm a Nordstrom quarterly shopper by third-party enrichment because there is user ID here. So, but it may be a bit harder to get to more granular details, right? So science, what's the science discipline? It's probably very hard to know that based on those queries that I'm in data mining. And probably no way to look into who the school is for. And it's very possible to get it wrong, too. So I see some laughs. So basically, I put a conditional probability. If you calculate the conditional probability to throw in the language, and you have the hint of Chinese language and harass, and possibly you might predict this user belongs to the gambling segments. So just to give a little bit background, the harass is known for utilizing data mining to gain competitive advantage, right? Especially their CEO, Gary Luftman, actually has written articles. And those articles at that time was buried, and maybe still buried in the PDF files in some schools. And the ones that I tried to search quite a bit, Eric Schadt actually is a computational biologist. He's known for trying to make a shift to a system-wide view of biology process, as opposed to from the traditional single-cell approach. But at that time, this article, if I show you this picture, actually article, at that time, the article was published in 2011. And the time I was querying, I made all of these queries because I heard his name in passing from a friend. So I don't know how to spell it. And there was no article, and Google was not suggesting. I kept trying. And the reason for these two, now you can see the connections. With the background information, if you had it, which was in my head, we could infer more. And this is because I was trying to look for these two persons. My goal was to look for a couple powerful data mining speakers for the data mining conference I was organizing. All right, so there's even more. It's even harder to have some sense about what I might be interested in the future, right? So future is quickly I turned into a tech hobbyist, which I'll show you a bit more. All right, have that in mind. But still, there is huge amount of data already. Like I said, billions of impressions, terabytes of data churning through every day, every minute, and to conclude things. And we have some challenges and achievements. So now, I want to just walk through a little bit more about what's behind the scene. So data mining as a science and a craftsmanship practice has been exist for many years, right? So this is a process view of what data scientists do. And in the center is data. What we work, the center of our work is on data. But the starting point is always from a business problem, right? Understand the business. And then, so for any data scientist, typically they would have a domain background as well. So as Maria introduced me, I had spent many years in advertising. So advertising is my subject domain knowledge area. And data mining is my technical area. And data preparation and modeling is an iterative process. You manipulate the data and try to build model to it. Models are, you're all familiar, you heard the words from many different places of different perspectives. But in essence, a model, a data mining model is a highly dense, abstract description of the data, right? So if you put a statistical distribution, a curve that describe the data, so that you just need a curve to describe the terabytes of data. So that's an abstract view of data. In advertising, let's say we're looking for tech hobbyists. So what happens in between, behind the scene? So first, we find the audience. Finding the audience is, you could build segments. I think most of you should be familiar by now, as behavior targeting has been out there for many years. You can do rule-based, you could do machine learning-based, you could do calculating probabilities, different calculation-based. So for instance, given a set of behavior, search queries, page views, what's the probability of this person is likely going to be interested in tech hobbyist stuff, right? So these are combining, imagine the long list of query, that's data, turn that into probability frequency calculations. Think of that. That you can line up all the users and calculate. By the calculation, you can select who ranked high, and then you can cut a threshold and pick your audience. And then oftentimes when the audience segment works well, we want more of it. So the next task is expand the audience. So you can say easily, okay, because I have the calculation, let me loosen the threshold and cut lower, I get bigger segment. And in fact, you will probably run into this if some companies offer this perspective. It's not necessarily always work. Maybe the model, once lower certain threshold, is no longer accurate, no longer, sometimes even worse than arbitrary, random, right? So, but there's some algorithm that's at work that we have done this for behavior targeting. And then validating the audience, once you find it, oftentimes I think some of you might be the customer, my past customers, and say, I bought your behavior targeting segment, it did not work, right? So what's going on here? We do validate the audience. So this is very hard to validate because when you have those data search queries and web page views, how do you actually conclude someone is tech hobbyist? The person herself may not even label themselves as a tech hobbyist, right? So in data mining methodology or machine learning, this you might see, you might have heard confusion matrix, and this is basically say, if we know a list of tech hobbyists, and then we compare the ones that you predicted, so the horizontal column, the row, yes, that I predicted, or no, I predicted it's not tech hobbyist. So you have a yes, no, 2x2 matrix. And then you would hear the words true positives, which means someone is a tech hobbyist, and you predicted also it's a tech hobbyist. And false positive is someone actually is not, but you predicted it is. So therefore, your targeting might have gone to the wrong person. You sent to someone who actually may not be in reality. So this is just one way of calculated validation. Of course, we actually have done different methods, because to really, really satisfy customer advertisers' requirement for accuracy, we definitely cannot be just throw a bunch of math to say, I did it, and it's your problem. No, we have to actually, we tried, for instance, survey, we actually tried also behavior comparison. So if you have a list of users from past campaign or from some rule-based description of the type of behavior you were looking for, we compared these users' behavior traits against what we predicted the users' trait and see how similar they are. Right. And then in this business, forecasting the inventory and optimize the use of inventory is also crucial. And oftentimes you identify the audience, but they make very little impressions in certain properties, and then you don't get to see them often enough. And then for the case when you see them, which ads to show to them, that's also a challenge, because you have competing priorities. Some others need to go first because of time, others need to go first because of price, and yet another other need to go first because of guarantees. And this is just can go on, and you could, in the end, also analyze the before and after behavior, as well as in-segment, outside-segment behavior. This, oftentimes, you could say, for instance, the type of analysis we have done include to look at the behavior before the campaign. Remember, we have the massive data already stored in the databases in the cloud, and then you can compare what they did after on search engines or general website usage. Ideally, you could compare against their shopping cart or transaction histories. But that's not always available, but you could do as much as the data become available. For instance, I showed just a visual, this Google Trends, you could analyze things. But, okay. That's just a very condensed list of type of algorithmic engines that goes behind the scene, and we want to do that all at scale. So we brought the business, behavior targeting business, from 0 to a very sizable business to about over 1,000 segments in 14 markets, sizable revenue. And in any of the initiatives and systems, we have to do it at scale. All right. So with that, I then, after behavior targeting, I left Microsoft. I went to do my startup tour of duty. Went to work on optimizing computer operating system and application softwares using big data approach also. And then now I come back to advertising again after almost 2 years, and there's quite a bit of reason to be excited. Now, so switching to today, as I started to look at the advertising again recently, about past a few months, and really compared to this linear data, and we now have, I see much more things to be excited. So throughout this, I use my own examples. Say, this is a post I made onto Facebook and says something about my son made a Raspberry Pi work. How many of you know what Raspberry Pi is? Oh, fairly good. So this is good then. So it's non-trivial for a 12-year-old to make it work. So I was really happy, and that's my TV he's posting there. He's holding the single board computer in his hand. So Raspberry Pi, of course, as a team, posted. So I'm just giving you examples. You all know this already, so I'll just quickly flip through. And this is my LinkedIn network. You can see the blue part, I think, is my China connection. The orange part is my Microsoft connection. So much to be excited. This is all out there. And then I mentioned in my colleague's post with a location, Palo Alto, with my connections and photos. All right, so these, now, as a data scientist, this opened up a huge, huge excitement and opportunities to work on a lot more exciting problems and behind the scene a lot more algorithms, because we now have, it's not just volume of data, it's the much more dimensional, many-dimensional data, and it's connected data. It's many other attributes I hope to walk you through. So now this basically, at any time, we have people at any location express some opinions or state some facts about certain topics. And this is fairly fascinating because there's a lot more to it. And with this, it's not just piled linear data and elongated, longer linear data. Now we have multidimensional. And there are a huge amount of knowledge embedded in those connections. So, such as audience graph. So one obvious, this is just not, I use a Facebook open graph just to show, but this is definitely not limited to that. In fact, all of your customer base, your user base, you can construct audience graph on top of it. And that's what we did that for Microsoft also. Entity graph and knowledge graph, I'm sure you all heard. Google working on the knowledge graph and shipping some of the features. The things that's being talked in that connected graph is having meaning now. We have access to the meaning of the things, right? And semantified, that's semantified content. For instance, this graph I show, maybe lesser known, is Academy concept graph that's being taught and shown to little kids as they take some courses on learn how to subtract and do divisions. That's all there. Semantic, you know the meaning, and you have actually more context behind it. This also was enabled by the knowledge graph, and I think you probably have seen the articles on Google's Hummingbird. And as you see, this got displayed as screenshot, blueberries versus raspberries. And the result is knowing, first of all, knows these two things are actually named entities. They are not just a string of text. They actually represent some real thing. And that thing, the thing has attribute. The thing, they look like that. The thing has attribute. It knows it's related to food, so therefore it has a bunch of food attributes. With those connections and location, time, and data, we actually have real-world context awareness now. Right, so in the old days, the Clippy is trying to do context awareness computing, right? You are somewhere, we try to make a suggestion to you, you are in the UI. But now, imagine much bigger scale, much real in the real world. You are in a physical world. That context where you are, who you are with, and the resources around you, right? And then to a data scientist, the most exciting part to me that really is close the loop, being able to close the loop. This, in my behavior targeting days, I can say how accurate I am with the segment. I can say how good I am at optimizing the use of inventory. But I can never really say how really effective that thing is without the help of others. Like the advertiser would have their own data, the third party would have their own data to measure the effectiveness. With the data now I just show, I hope that you agree with me that we are really turning a observational analysis into experimentational analysis, right? So now just like study patients, you can only observe, you can try to suggest different treatment, but you don't know what's the result. And so now we start to know the result because the consumers are telling you. Okay, so with that excitement, I want to propose to look at this whole picture in a higher level abstraction. And this is the introduction of the wisdom pyramid. And this picture, credit to a famous author and published 2003, this pyramid. Before the search engines, before Google's success, we were at the bottom layer, the data layer. So we know things happen. So the data is just a concrete facts, a discrete fact about an event. Someone clicked a link. Someone even made a query. So that layer. And Google brought us to the information layer, of course, with their goal to on the information technologies. And they successfully did so. Now, as we move into the knowledge layer, and I showed you a little bit about Google's knowledge graph, other people's entity graph, and we are, as a internet, as the consumer space, we're getting into that knowledge layer. And what does that mean for advertising? So at the bottom layer, we used to show ads at just very reactive. You are on this page, you see this ads. You search this query, you see this ads. Well, search ads could be somewhere in between a little bit if you do a lot more information type of things behind the scene in batch mode and remessaging there. As we into the, I would argue behavior targeting is in the information layer. And maybe a little bit above, closer, because depends on how much contextual information we're getting into the behavior targeting. And perhaps as behavior targeting evolves, we can get into the knowledge space. That if the keyword here is in the knowledge space, we apply the context to the message. And this you're familiar, you already heard from other keynote speakers, including yesterday's speakers, all point out about the context. So my hope is that I demonstrate and show, pointing the way to the context as demonstrated in data. Context understanding capabilities in data mining capabilities and algorithms. So what does this ask me here? What's the implication here? I would frame it back to the title of my talk, knowledge-powered audience engagement. So in building the knowledge systems, you've seen the graphs, you've seen the data. Let me show you some of the key components. So we start with data, structured data, unstructured data, things you get from the web, things you get from your operational database. We go through, build various knowledge extractors. Right? So those knowledge extractors include various algorithmic engines. such as classification, sentiment analysis, opinion mining, ontology, entity, facts, relationship, extracting all of that from text, from images, from, these things. What I'm talking today is not necessarily only limited to text streams. We feed those facts into organized graphs, right? User graph, entity graph, and I'll show you some as we go. With that system in place, the knowledge base here, the blue box here, is just a collection of knowledge bases. You can think of entity graph as a knowledge base, audience graph as a knowledge base, a set of knowledge bases interconnected together with inference capabilities, right? So with this post, on top of the knowledge systems, now we can provide recommendations, because now we have some understanding of what the user is saying, right? So perhaps we can recommend what to say to people who do this. And perhaps we can observe their later on post and feed that data back into the system. That's the feedback loop. And this is critical because all of these engines at the bottom needs to be trained and iteratively improved over time. And some automatic learning, improving itself. Some needs to be having a data scientist involved to retrain the models, right? So I want to walk through some details about entity and semantics, such as using this example again. In this post, we can see extract the entities in this: Raspberry Pi, Palm, Lego, those, Erlang. Erlang is a functional programming language, and that's what I tried to apply in my previous startup before Parllay. This, you all know what Raspberry Pi is, right? So the semantics is assigning meaning to those data. So for instance, this is a description of the type of semantics you could apply, the type of representation. For instance, Erlang is a functional language. Raspberry Pi is a single-board computer, right? This knowledge, this entity graph knowledge embedded, and is actually available. For instance, you will find this. I actually constructed this from Wikipedia, right? It's doable today. It's publicly available, and it's not a huge technical barrier to construct. But of course, you do need really sophisticated engineer to build it, but it's doable. And the ways to derive semantics, that just put in a little bit of detail for you, you could use statistics to associate meaning with concept. If Raspberry Pi is often associated together with teaching computing, then you can make that association. Lego with toys and play, you can make that association and conclude that, assign that meaning to the entity Raspberry Pi. Okay, so I give you a little bit more about recommender systems. And recommendation system takes the data. First is the user profile. What do I look like? My age, my gender, what have you, that you collected, that you think important to your business, to your products, to be helpful to make recommendation. And then also the community data. Recommendation often have to have the community data. So you all know this, we are hometown to the best recommender system, the Amazon, recommending products to people. And you have, of course, the product features and the knowledge model that often goes together and make recommendations. The recommendation usually is a ranked list of entities, a ranked list of products, right? So you basically imagine data, lots of tabular data through matrix computation and outcome a ranked list. And that's what you see with Raspberry Pi. You get recommended the cases, the accessories, right? And well, I see a Google Glass. And because I was going to use that as an example to talk about the knowledge, right? So this is an audience-based recommendation. So a user, because what we know, the user, people that similar to me tends to like this kind of product and recommend this. Now, imagine with this example, what do we do in this recommending system, right? So this graph, now Ying is attached to Erlang, John is attached to these three things that's discovered from this post, all right? So what would you recommend? And if we plug this data into a recommendation engine, work through that, potentially you could recommend ML. ML is another programming language, functional language. So because there is very limited information about Ying on this isolation, I'm trying to depict the picture. If you don't innovate new algorithms, just use existing recommendation engines, you could still plug in new data to work. But potentially you may not take a full advantage of the entity graph. Okay, so now, putting all of this together, the entities, the semantics, the audience graph, the recommender system, what does it look like? So we have this entity extracted, right? So now I want to show the excitement is that with the social mobile data, the type of new things we could achieve. Here's one now. Now, I made a post again about 10 days apart, and I said, posted another one about my son took a robotics course. So here, the entities we extracted are Johns Hopkins, LMU, and robotics. So let's focus on robotics. Now, John has a new connection to robotics. And robotics is part of robotics hardware, right? So now, if you look at the entity graph, look at particularly at the higher level, you go from the user to the entity up into the hierarchy of the knowledge base. And you look for co-occurrence, you look for higher frequency, you look for more weight to recommend. I think you will conclude this Arduino. I assume many of you know what Arduino is also, right? So now, we're getting to a new space now, because in the previous recommendation space, Arduino was not in that recommendation space, meaning for anything to be recommended, the system needed to know ahead of time in order to recommend. But if something is new to the whole system, you would never recommend that. But with the knowledge growing, the graph, the connections, now you can start to see things that you were not thinking about recommending because the system did not know. Now it's possible because this case, particularly Arduino, have a much heavier weight than any other entities to be recommended because it's across multiple categories. And sure enough, actually, if you just calculate the probability of buying Arduino with Raspberry Pi itself, the probability is probably low. If you combine that with robotics, absolutely high. And I name it as unsupervised prediction. Now, we're basically anticipating what's going to happen in the future, right, for the user, for the audience. You can start to learn new concepts as you grow your entity graph, and then you can start to make recommendations. But it's a newer way than before, and possibly make some, anticipate into what the future, what the user might like in the near future. All right. In summary, think about connected data. So when you think about data, now I showed you different data, linear data, multidimensional data. If you just pile them together, the power is less powerful. But if you combine them, as a data scientist, in my experience, oftentimes when you combine data together, much more power comes out. It's not 1 + 1 = 2. Think about semantified content. The post that I made is no longer just a string of text. It is about computing, it's about single board computer, it's about school education, it's about hobby. And feedback loop enabled machine learning, right? So with the newer post feeding into the system, you could learn more and predict more, and then you can continue that virtuous cycle. And knowledge-driven content recommendation is once you know you have anticipation the type of things that the user might be interested, you can make a new recommendation. And this leads to an audience-centric content curation. So you can imagine a system where you could describe the audience, describe the things they did, describe their conversations. This would help you in the audience to create the type of the contents for your conversation. And again, I'm not talking about manual. This, I hopefully show you the scale that machine learning, big data, computing power can do this all at the scale. So this is why I'm excited to coming back to advertising space. I'm working with Parllay. As of today, those capabilities I'm talking to you today are, especially the second half of the talk, are at the science level. We're working on the algorithms, we're working on the data systems, but I believe you can expect in 2004, I believe you can expect and you should expect some of the platforms start to emerging, some of the capability to help you curate the content by assisted with knowledge at scale because it's a system for you. With that, I do a quick show of video. Thank you, and have time for a question.
Hi, I was curious how privacy concerns fit into this more advanced audience targeting when you're combining personal information like on Facebook posts, or I would assume Twitter or other public available sources of data, and then combining it with that individual's interactions on your site or other information you would have?
Yeah, very good question. Good question. I actually was a privacy officer on the engineering side for Microsoft Online Service. The reason the division head picked me actually to build up a privacy structure, compliance structure, official structure in Microsoft organization was because I work with data, I had the knowledge of the data. But to answer your question, yes, I think there are two parts based on my experience. One part is what you say you're going to do. So you always have to follow what your promise to the user, and you also have to follow the usage, the data usage rules. What Twitter says that you could do with their data, right? What Facebook says you could do with their data. You have to follow this. Your own promise and the third party's promise. You have to follow that, meaning you actually, in designing the product, you actually build those things from day one. You actually design the data model in such, if you need to be completely getting off real user ID, you have to do that transformation, right? You have to do the one-way hash so that you no longer know that's who really they are. That's one side. The second side is there are innovation area needs to happen still. That the data usage sharing, indeed, when you combine data, things reveal. Right? So basically saying, I want to anticipate what you are going to think, what you were going to do. But in the meantime, I kind of where does the privacy sit on that one, right? Did I violate your privacy when I say you were going to buy an Arduino, right? So I don't have a complete answer saying that we guarantee your privacy. That guarantee, as a commercial guarantee, need to have money associated with it. I don't see anybody in the whole industry doing that. So that's partially because it's very hard to do. It's very hard to do. I have led teams to actually try to innovate in that space. There are existing research happen in the past 10, 15 years already. The discipline, the approach called privacy-preserved data mining. There's other approaches as well. We actually experimented at Microsoft Days, trying to implement some of these privacy-preserving algorithms into the engine. And we can, because you follow the algorithm. The algorithm is mathematically proven privacy-preserving. But if you follow that algorithm onto the data, you have to have the segment into certain size. That size make the segment becomes infeasible to sell. Right. So this is where we still haven't achieved that eat your cake and still have it too. Right.
So for a general marketer who is maybe working with a data scientist or who's at a smaller company that doesn't have access to that, these general marketers are still expected to become more analytical and work more with data. So what, I guess, skills would you suggest that like a general marketer focus on building in order to become more analytical and take more advantage of the data that is available to them at whatever level that may be?
Mm-hmm. Great question. I love that because I think in my heart I was a teacher, the imparting knowledge. Yes, I think when you ask that question, I assume already you have a built-in desire and a natural inclination for analytics. So let's take that. I think it's not that hard then, because that's the critical piece. If you're drawn to data naturally, you actually think analytically as usual habit already. I think it's not that hard to learn some of this. So in my last talk a couple of weeks ago, I made a challenge to people to say, so actually just go take a public data set and then just spend, say, 2 hours and try to discover things, right? So this would the best way. So I guess in summary, I would say is the best way to do this is to learn this is by doing it. The way to do it it's actually not that hard to get started. you probably, by the way, I'm saying that because I in the middle of preparing, getting a course ready to teach, saying, how do you discover knowledge from data in 1 hour? How do you learn to do that in 1 hour, right? So there are lots of open source tools. And if you work for some entity, you may already have analytic tools. Just use that, whatever you're comfortable with. If you have nothing, maybe you pick one. The R as an open source is very powerful. It's reasonable, easy to use. And there are so many public data sets available. Just follow it and do it. And maybe make some friends with some data scientists. Yeah, I saw the Google Glass because I thought that's a good example too for context awareness, because then you could, from the end user perspective, you have the awareness, meaning the resource to you, that you can make that decision. You can operate as the engine on your own. So what I described here is the platform side, where if this glass is willing to feed all the other signals into the platform, now the platform has one more source of signals for the context. Any other questions? Thank you.